Hello, and thank you for joining the SaltStack webinar titled Predictive Orchestration with SaltStack. My name is Rhett Glauser. I'm happy to introduce our two panelists today. We have Mark Hopper, who is a technical solutions consultant with SaltStack, and he'll be running the bulk of the demo that we'll share today and providing the technical deep dive into how we do predictive orchestration and what that actually means. And I also have on the WebEx here with me Matt Maservi, who is head of our SaltStack product, and he'll provide just a quick intro into what SaltStack is and what we can do, and then what you can do with the software. A couple housekeeping items. Just as a reminder, we are recording this webinar, and we will make the recording available to anybody who's registered for the webinar. So you'll be able to share it with coworkers, friends. We'll get that recording to you within about 24 hours. Also, if you do have any questions, and we hope that you do, please make sure to use the WebEx QA question and answer function within your WebEx panel there, and we will try to get to all the questions. So with that, it's my pleasure to turn the time over to Matt and to Mark. Matt, take it away.
Thanks, Rhett. I appreciate it. Welcome to the SaltStack webinar, everybody. My name is Matt Maservi. I'm the Director of Product Management here at SaltStack. And I'm excited to be with you guys today and talk a little bit about the solution and hopefully how we can improve your lives and make your jobs a little bit easier and help you manage the modern infrastructure and get the jobs you're trying to get done as quickly and easily and with the least amount of work as humanly possible. A little bit of background, I've spent about 15 years in the IT systems management industry and with the companies like Symantec and EMC Legato. So I have a long background here, so I've actually been a systems administrator in charge of a fairly large infrastructure. I understand sort of the needs and the demands that you guys are going through, and so we're excited to be sitting here today and being on the kind of the leading edge of the modern and the new infrastructure. So one of the things that we want to talk about today really is it's modern systems management. What we're looking at is another generation, and it's interesting if you've been in the industry for more than a couple of years, really. You'll see waves of tools sort of roll through which address the needs of the infrastructure as they appear. And early on it was simple systems management. It was the ability to do things in batches, and and then we started to see a little bit more complex or progressive tools like the virtual infrastructure and those kinds of things. Well, infrastructure of today, if you're tracking the numbers, has exploded. It's exploded in both size as well as complexity. And the other thing that's been sort of interesting is that the modern infrastructure, with the rise of the DevOps movement, which is there's the traditional development and then handoff into ops. And it's interesting for two teams that work so closely together. They really have diametrically opposite concerns and views, and the development team is tasked with providing solutions as quickly as possible and getting them built and pushed to the infrastructure. The infrastructure team is tasked with keeping the infrastructure as stable and as available as possible, often with way under budget and way under staff. I haven't run into anybody outside of the government industry yet that is over budget and has as many staff as they need. And so the DevOps movement arose, which tried to help shorten that cycle a little bit and help those teams work a little bit together. And what that's given rise to is this trend of infrastructure being more than just hardware or just computer storage. Infrastructure today, when you're talking about an application or a service, infrastructure is starting to blend into that. So applications today are considered more than just code. They're the code itself, they're the process used to deploy the code. They're the infrastructure. It's the infrastructure that's used to manage the code, and then that infrastructure, as it's become more integrated, and the infrastructure itself has become a basic part or component of the application, it's exploded in complexity and the rise of things like microservices, which is yet another generation which is yet similar to the virtualization wave of a few years ago, and cloud infrastructure and public infrastructure and those kinds of things are enabling people to build increasingly complex infrastructure and build it on a scale which has just been unprecedented. And so what SaltStack is really designed to do is help you manage that. So SaltStack is really pitched to help you manage the modern infrastructure from the very beginning of the application, from the code and deployment and initial testing, out into the actual hardware stack itself, so that you're able to manage that process from the very beginning to deployment into a complex hybrid cloud across multiple public cloud or public-private cloud infrastructures. So SaltStack really is, a lot of people know us, a lot of people in the DevOps space know us, and they use us to automate infrastructure in order to start that process. And we have lots of customers who use us in the config space. And really what that does is we really are trying to educate our customers that not only DevOps and not only config ops, but also cloud ops, so full stack, hybrid public cloud orchestration from the very beginning of the app. And Mark Hopper, my colleague, is going to show you a little bit in greater detail later how orchestration works and how dependencies work and how you can start with a piece of code and end up with this very complex infrastructure with dependencies and maps to other pieces of hardware, all assembled into the application that best serves your company's needs and help you drive business, all very quickly, all very easily, and with a minimum of staff and input. So SaltStack contains a couple of tools. They contain the remote execution engine, the config management engine, and the orchestration engine. And what that gives you is this intelligent and predictive automation of everything in your application stack or in your data center, from the code all the way up into the hardware. We pitched this and we recognize amongst our users and buyers sort of three main buckets. Now, each of these can be subcategorized or subdivided a little bit, but there's sort of three main buckets of use cases. We'll talk about these as we go. Later on in the demo, Mark's got a part of his demo actually goes up and spins up a bunch of infrastructure in the cloud, and it takes a few minutes. And so we'll have a chance to talk a little bit about how these buckets divide up. But largely, we see our customers fall into sort of three spaces: the DevOps community, who is generally pitched at the development of the application and helping push that application out into the infrastructure; the ops community, which works with dev to get that deployed; then the traditional IT ops, which are traditional config management. They tend to handle data center infrastructure. The infrastructure is largely static. It sort of grows and shrinks in small increments, but it's traditional infrastructure, so patch and virtualization, those kinds of things. And then cloud ops users, who are traditional infrastructure managers, but they're dealing with very scalable, very dynamic infrastructures, which are maybe scaling up and scaling back based on demand. You're doing compute on demand. You're doing public, private, hybrid clouds, those kinds of things. And SaltStack is designed to address all of those from the beginning to the end with a very open and efficient and very, very fast infrastructure. So the last thing I'm going to say to you before we go is that SaltStack has this is an interesting slide, and this is just to give you a glimpse behind the curtains, I guess. Internally, this slide's had a lot of debate, and everyone that looks at this slide takes something different from it. And I guess in a way that's why this is one of the best slides in the company, is because there are many elements of SaltStack. So we've got the master minion layer, and we've got beacons which allow you to monitor, and we've got syndics which allow you to spread infrastructure wider, and we can manage public clouds and private clouds. We can do all of the things which the modern infrastructure stack needs you to do in order to automate, build, and orchestrate your application build, test, deploy, management, ongoing management, and then replacement with the next generation of your app as you go forward. And so as you look at SaltStack, just like this slide, decide what you need to do to get your application and your business running smoothly. Decide what and where we can automate you. And each of you will probably take something different from Salt, and each of you will probably use it in a way that best suits your need. And that's really one of the best things about Salt, is it's flexible enough and powerful enough that it's very rare. And this is actually one of the benefits of being a product manager at Salt. It's very, very rare we run into use cases. And actually, when I say rare, I can't think of any yet in the modern infrastructure stack that we can't automate and orchestrate and take care of for you. So pay attention to the use cases. Try to think about those as you go. Feel free to throw questions at us. I'll be, as Mark is going through his demo, I'll be monitoring the questions. We'll pick some of them up in line, and then the rest of them we'll address at the end. So with that, I'm going to turn the time over to Mark Hopper. Mark, take it away.
All right. Thank you very much, Matt. And let me back up here. Somehow we skipped a bunch of slides. So I'd like to start the discussion with just some SALT architecture, just to kind of set a level set. We have several people attending the webinar, and some of you are very experienced with SALT, and this is going to be a little bit of review. Some of you are probably new to SALT, and so this can kind of help you understand some of the major components, particularly those components that are part of the demonstration today. And so I'm just going to kind of basically give you an overview. SALT really is, at our core, we are a remote execution engine. We are a client-server type solution where we have what we call a SALT master, and we have an agent that runs out on a system or a node, and we call that a minion. Minions do what they're told, so that's kind of where that comes from. And they communicate over a high-speed message bus. By default, that's 0MQ. The minion initiates a connection to the master. The master, there's some key exchange for an encryption, and then you have a persistent connection between the machines. Basically, how the communication works, and again, this is the core of SALT. SALT, this remote execution engine and this message bus really is the magic sauce, you will, of SALT, differentiates us in the marketplace. But at our core, what we are is you have a targeting group, and you have some instruction set, and that can be in the form of a module and a function and some arguments. The master sends that across. The minions that meet that targeting criteria execute the instruction set and then return data across that event bus back to the master. The minions do all the heavy lifting with the modules. They reside on the minion. There's hundreds of modules that exist out there due to our community, and that's basically the function. This example that you see here is kind of an example of a single command line function. However, if you wanted to lump those together, we create what's called a state file to put a machine into state, or an orchestration file can leverage the same kind of thing from an orchestration standpoint. But ultimately, you have a target and some instruction set, and that's basically how we function. There are some things that we actually leverage in the demo, and I wanted to talk about those a little bit. They're data sets. Minions have attributes, whether that's an IP address, whether that's a role, whether that's what version of a particular application. We store those things. We call them grain data, and you can target against those. So you can target all your Ubuntu or all your Windows 2012 boxes. You can target all your machines with a role of web server. So grains are very accessible to use in targeting. That data resides on the minion. We also have another data set called a pillar. Various information is stored in the pillar, configuration data, for example, and I'll show you a little bit about that later on, but you can store configuration management. You can store data, sensitive data like passwords, things. The master is the one that controls that, and it's really the only one that has access to that. But typically pillar data is minion data as well. And then we have this thing called a mine, and I'll explain. In the demo, we actually leverage the mine as well. The SALT mine is typically where you store minion data for other minions. So if I'm configuring, if I need configuration about, and I need to configure my machine to target node A and node B, it can gather information about node A and node B out of the SALT mine. So we will talk about that here and how it relates to predictive orchestration, and particularly how it relates to my demo that I will be showing you today. The last piece of our architecture that I want to talk about is our reactor system. And really this reactor system is what drives predictive orchestration. The reactor is listening to this event bus, so any data that comes across that event bus from any minions in the environment, the reactor can then react to a particular event and send that and start a process. And that could be as simple as notifying somebody with a SMTP email, or it could be as complex as spinning up an entire environment, in there. So it really can just react to those events. A sister piece to that would be a beacon. Beacons are pieces of code that sit on the minion itself, and they're watching for particular events to happen on that minion. So things like failed login attempts from a security standpoint, or CPU load. If the CPU spikes, the beacon can then, based on a threshold, fire off an event into the reactor. There's several beacons that we have out of the box. Today, I will be specifically showing you what's a service beacon. We'll be watching a particular service, and then when that service fires off, it will actually go off and then the reactor will react to that event. And this is really kind of the core architecture of SALT in predictive orchestration. So throughout the presentation, I will try to identify which of these components are going off as part of the demonstration, so you kind of see how they relate to that. So let's go into my use case. There are several use cases out there, and we may have time, like Matt said. This does take a few minutes to run once we get started in the live demo, but there are several use cases where this will work. And in my use case, I'm going to relate this to an application stack. So you have front-end servers, you have back-end servers, and you have middleware servers somewhere in between. And this could be as large or small as you want. And that brings some complexity. If you need to replace anything, you need to make sure that the upstream servers can communicate with the downstream servers. So there's a lot of different pieces and moving parts, and this can be complex. And this can actually, if a middleware server were to fail and you didn't have any automation tools, this could actually take a lot of time to configure the new middleware server, to go through all the configuration files and make sure that they're all talking to the upstream servers and make sure that they're talking to the downstream servers and that all that communication happens. So this is the use case that I'm talking about today. So let me just kind of give you a visual example of what we're going to see on a scale here. So we have a stack with some middleware servers. One of those middleware servers fails. What happens? So we can automate the fact, and instead of trying to fix that middleware server and to do a root cause analysis immediately when you're down, when your systems are down, what you can do is you can bring up a new middleware server. So you need to bring up a new server. You need to configure that server to talk to the back-end systems as part of it's just your typical configuration management pieces. But you also need to orchestrate and reconfigure the upstream components to talk downstream. Because middleware server 1 in this case needs to talk to the one that has died, and that's going to either have a particular node name or IP address or some kind of unique identifier, and you need to configure that. Salt can actually help orchestrate that and can configure those upstream servers to talk to the new downstream stack, and at the end of the day, you have your initial system up and running again. And Salt can do this in an automated fashion. And ultimately, this is kind of my use case that we're going to demo today. So let me get a little specific about what you're going to see in the demo, because typically when things happen automated, it's happening in the background. So I kind of want to explain what I am doing. So I've kind of simplified this. Your downstream servers are typically part of the configuration of a single upstream server where you configure it down. However, the same concepts apply. So just for the sake of demo and for the sake of time, I've simplified that. So I have a single front-end server, and then I have a middleware server. In my example, any back-end servers are being configured as part of the middleware server being configured. And so I've really simplified this down, again, mainly for the sake of time and simplicity to talk about the concepts. So what do I have actually? So I have my front-end server as an HAProxy load balancer. So it's fielding any external web requests to HAProxy. And then I have my middleware server, or my back-end server in this case, is an NGINX Web server, fielding those web pages. So if we look at what's going to happen in the demo, I'm going to have NGINX running. We're going to have a beacon watching NGINX. NGINX is going to fail, and then the reactor will then go ahead and spin up an orchestration routine that spins up a new NGINX server. That server, these are being done in the public cloud, so that NGINX server is going to have a completely different IP address, and in my case, it will also have a different host name. And so the load balancer needs to point to the new NGINX server. So the orchestration will, in configuring the upstream servers, will configure that load balancer to talk to the NGINX machine. So that's really the kind of a high-level overview of my demo. So I'm going to come out of here, just kind of show you a little bit what I have. So here is my the statistics screen on my HAProxy, and you'll notice that I just refreshed it so you can see I have web server 01 sitting behind this HAProxy. Now, in a real world, you probably would have multiple web servers or application servers sitting behind this load balancer, but just the case for simplicity. Some other things that I have set up here is some terminal windows. I have this terminal window right here is actually my web server. I'm going to use this to simulate service failure or application failure. This window here, this is actually monitoring the event bus. So right now, nothing in my SALT system is happening, but I am actually showing a live feed of my event bus. So if we go back to the architecture, where the minion is talking to the SALT master, all the communication, whether it's going from the master to the minion or the minion to the master, is happening across this event bus. And so this is just kind of a live feed or a live stream of that. I also have a terminal session into my actual SALT master, and we may look at some things there. So let me just pull these. We may look at some of those things later while this is building. So let me go ahead and start this. This is going to happen, if you notice on the left-hand side, that is my event bus. Things are going to start streaming there very rapidly. I just want you to see basically not necessarily the events themselves, but the fact that these events are happening and that the minion is talking to the master. And then we will kind of go back into a graphical representation of exactly what's happening here. So what I'm going to do is I'm going to go ahead and, in my example, I'm going to do an unclean shutdown of NGINX. And the beacon is actually monitoring for any kind of state change. So anytime the state of the NGINX service changes, the beacon is going to fire an event. So that's going to fire an event on failure. If it starts, it'll fire an event that it started. But this is an unclean, and I'm specifically looking for unclean shutdowns of NGINX. And there's every application is going to be different how you can determine if the application failed. This is just one example I use to simulate application failure. So I'm going to go ahead and kill the NGINX service. And as you can see, the events are now starting. So what has happened is the service failed. If I go here, you can see that web server 01 has failed. And if you keep continuing watching, you can see events float through here. And so now the reactor reacted to that event and started an orchestration routine, and we're up and running. So let me go go back into my presentation here, because I've got, while this is going on, I've got some explanation of actually what is happening. So here we have the master. We have a minion. They're talking across the message bus. I have a beacon that is watching the NGINX web server, and from here. So when the first thing that happened is I went and I killed NGINX. So the NGINX web service died. Once that happens, the beacon fires off and says NGINX died, and it sends an event across that message bus. The reactor is watching, essentially watching that stream, like that I was showing in the screen there. the reactor is watching that event, and based on criteria of that event, fired off. Now, you can actually have the beacon firing events in multiple cases, and the reactor can react to various events, and you can configure the reactor to watch for a specific event. So that's important when you start talking about orchestration from that perspective. Once the reactor sees that event, what happens is the reactor then fires off an orchestration routine. An orchestration routine, we use a couple different words that kind of basically mean the same thing in most cases. The orchestration routine is written in YAML, similar to our state files. Some people refer to them as runners. Some people refer to them as master-side state files. But ultimately, it's a piece of code that tells the Salt master what to do and what order to do that in from an orchestration routine. So what is happening in my orchestration routine is the first thing it does is it noticed that the NGINX server failed, and then it notifies me that machine failed. And then for the sake of demo and the sake of the way I build my demo gear, it actually goes and restarts NGINX. And the reason I put that in there from a tactical perspective is it makes future demos for me easier, but it also shows that instead of spinning up a new box, we could easily repair the failed application if you knew what would take to repair that. So the other thing, the thing that my orchestration routine does is it goes out and spins up a new machine. In my case, it spins it up in AWS, and then it will install NGINX on that box. So NGINX then becomes running, and then it will go out and reconfigure the load balancer to point to the new web server, and that's ultimately what my orchestration routine does, and then it notifies me how that's done. So let me go in and show you a little bit of the let me show you what this orchestration routine actually looks like. So here is the actual orchestration routine it runs. I store everything in GitHub, so this is my Git repository there. The first thing it does is it notifies me via, we have API integration into Slack. We use Slack here internally for internal chat. And so the first thing it does is says, look, we have a web server failure and it's spinning up a new node. And then it goes in and starts to spin up that node in AWS. And then it notifies when that's finished. And you'll notice, Matt talked about how we can do dependencies. You'll notice that it's waiting for Minion setup to finish before it actually notifies me that the migration of web server is completed. So this is where I actually can do some declarative instruction set where I can dictate what order things happen in my orchestration. If the order didn't matter, I just would leave off this require statement, and things would be happening in an imperative. And you can it's kind of cool that Salt's imperative and declarative at the same time. The next thing it does once that machine spins up is it reconfigures my HAProxy. What's actually happening here, if we go back to my architecture discussion, is that the mine stores the IP address. So what's happening is it actually is going to the mine to grab the new IP address and reconfiguring the HAProxy in that case. So that's kind of where that piece is there. And then the last thing it does is it leverages an API call to notify me. And the reason I use Slack in my demos is just to show that we can integrate with third-party products via API, either through sending a REST call, or in this case, we actually have a module that does that REST call for us. But we can integrate with third-party systems that you may having that from notification perspective, or to configure an application via those APIs, various integrations there. Let me just show you a little bit of code. So right here, what we have, this is the reactor. So the reactor is a SLS file that sits on the box, and it is, you'll see that it's looking for the beacon from NGINX, and then when that beacon fires, it goes ahead and applies that orchestration file that I just showed you. And that's very simple code there, and this could be as simple or as complex as you need. This other piece that I have here is the actual beacon. And this is, if we go back to the architecture slide where I talked about pillar, and pillar storing configuration information. So here we have NGINX beacon that is stored in pillar. So when a minion starts, it goes to pillar and it gets this beacon information. Okay, turn on the service beacon, watch the service NGINX, and fire off an event on change in status of the service. And then here's the criteria that it's looking for: unclean shutdown. It's looking for a particular file in NGINX case. Every application is absolutely going to be different. So it's just kind of an example of where pillar can store configuration information. In my case, it's storing beacons. However, it could store other configuration information as well. That's kind of why I want to go over that architecture thing. If I go into my Slack here, you'll notice that at 10:26, I got the first notification that the web server 01 failed, and then a few minutes later, it finished the migration of my web server to the new web server, and then it finished my load balancer. So if I go back to my load balancer and I just refresh this screen, you'll notice that it, and again, for the sake of a demo, I restarted web server 01, so it's showing restarted. In this particular case, in the real world, you would probably remove web server 01, and we could easily do that, remove that information. But you'll see that it also configured dynamically, automatically configured it to go to web server 02. And just for the sake of showing you that this actually is working, let me just go to the front end of this web server. And I want to delete that. And you'll see that here it's sitting a machine here, the IP address of that particular box. If I refresh, you'll notice that it rotated through the second box. And these are just AWS names that's throwing up there. I didn't configure it to actually show the Salt name, but you'll see that it's rotating through those, and that's all configured. Now, this predictive orchestration, again, I was looking at a case of watching a service. There's other examples that this could happen. So let me just kind of briefly walk through another example. I don't have a demo for this, but it's basically the same demo with a different beacon. So in this case, I have a single machine that's in an environment that's maybe cluster aware, like ELK or maybe Hadoop or something like that. If the CPU load within that system exceeds a certain threshold, then the beacon, you can have a beacon watching that. That beacon will fire, and then it can spin up 2 more minions. In my case, it'll spin up 3. So now it'll spin up the other pieces of that cluster, but it can, similar to what I was doing with the HAProxy, it can configure the entire system, whether that be ELK or Hadoop, to now process the load across all 3 of these machines there. So if we were to just kind of relate it to what I'm doing, we have NGINX, that machine gets loaded, it brings up 2 more machines and has, brings up other applications within that web farm in this particular case. But again, this can happen across an ELK stack, a Hadoop cluster, anything like that. So that's the demo of predictive orchestration. There are various use cases. I think, Matt, you may have some other cases where predictive orchestration, other use cases that might fit in your environment. Do you have anything that you wanted to?
Yeah, Yeah, we've actually got a couple of different questions that actually relate to your demo. Would you like to talk about those now, or do you want to talk about some of the use cases?
Let's go with the questions.
Okay, so the first question, and I think it says in a real world, the first question was, in your example, the Minion service, it's assumed the Minion service itself is up and running on web server 1. The questioner wants to know, how would you monitor if a server dies completely, assuming the Minion dies, or maybe you don't even have a Minion on it? Do you have a couple of suggestions how you would monitor a server if the Minion itself were to die?
Yeah, so I do. Actually, there's several different ways you could do that. You could be having some kind of small process making sure that these minions are connected, and if one disconnects, the reactor could react to that. Typically, in a typical environment that I deal with my customers day in and day out, there are other systems out there that are monitoring, such as Nagios, Microsoft Operation Manager, SolarWinds. The reactor system can also be configured to be monitoring for third-party events outside the SALT system. So in my example, I had the beacon monitoring an application, and the beacon fired off the event. In the use case that's in the question, I could have Microsoft Operation Manager or Nagios or SolarWinds monitor if a machine fails. The event could be coming from those systems into the reactor system, and then at that point, it's the same process. It's a great question.
Yeah, that was a good one. That's why I told the questioner we were going to hold that, because it is a really good one, and that's one of the things in that, you know, if you talk about IT operations, both IT ops and cloud ops, that's a very traditional thing to do, is to monitor a third-party server for whatever reason. Either you don't trust that the server itself will stay up, it's better to have a second level of monitoring. So SALT, back to what I said earlier, the flexibility of SALT allows you to architect the solution which best matches your needs, whether that's a reactor monitoring from another box or integration with a third-party monitoring tool. And from a best practices perspective, that's probably the cleanest way. Is most people who are managing infrastructure of any sort of scale are already using some sort of a packaged monitoring solution. You could just tie those things together and then react to the things that are happening. Okay, we had a couple of other questions here. One of the things, and this is more of a best practice or a concern. It says in a real world, is automatically spinning up new resources when existing bits fail can pretty easily cause a creation storm loop of VMs being created, which don't function as well, causing more VMs to be created. What are some of the recommendations to avoid spinning up VMs which may be not functioning, you know, as they come up? Do you have some suggestions there about how to avoid that, just automatically spinning up new resources? You and I, just a little bit of past history. Mark and I have worked at other management companies, infrastructure management companies in the past, and we actually worked on a workflow business process automation engine. And one of the things we used to say there is that bad process automated is just a lot more bad process, and I think that sort of fits this model here. So do you have any recommendations to avoid spinning up new VMs which may not be functional?
Yeah, so there's several different things that we can do in this regard, and this is where you start to add more complexity. Depending on the example, depending on the system, the first thing that comes to mind is you may want to have an approval process or some piece into that to make sure that the spin up starts appropriately. We have integration, for example, into ServiceNow, and you could actually integrate and have it actually spin up an approval process within a system like ServiceNow. We do have integration in ServiceNow. Once that's approved, it automatically starts that process. That's one way to do it. The other way to do that would be to have the reactor system as part of that. So you can actually have reactor start the spin up process, and if if it's succeeded, can, have the reactor process continue on through that, maybe with another reactor, or if it fails, it just stops right there and doesn't keep going.
Yes, that's a great answer, and this is one of the benefits of being of working at SALT is we almost always say yes, but the downside of the flip side of that coin is very often our answers are all preceded by it depends, and this is another one of those examples, and that it would really kind of depend on what you're trying to do, and Mark has identified probably one of the best ways to do that is have the reactor monitor for a number of instances and have a cap on that or number of iterations. The other way to actually do that is to use a SALT runner, which actually checks for data. It pulls data back. So you can actually have a runner queued to go look at one of those machines. If it doesn't get the data it sees or see what it wants, the reactor or the runner could actually stop the process. And in the new SALT Enterprise product, which we're hope to be shipping sometime early next year, we actually have notifications. So you'll actually be able to break out and notify someone and say, hey, something's gone wrong here, and then you can actually ask for human intervention there. One of the questions which came in kind of out of band, which was how does all of this work with containers? And that's one of the things I think probably that I skipped over at the beginning. When you look at the slide that looks like the SALT lattice, really when we're talking about managing infrastructure, we're really talking about the old school monolithic infrastructure to the brand new microservices, individual containers, whether you're talking about Docker or NSpawn or any of Lexi, any of the many container technologies on the market today, the orchestration tool and the fact that SALT, this is an interesting point, and I think will probably make more sense. In the old way of managing infrastructure, and we keep talking about this old and the new ways, but one of the things that will illustrate that the best is in the old way of managing infrastructure, everything was sort of reactive. You sort of waited, and then you would see what state a server was in, and then you'd run a job to try to get back to that. SALT has sort of changed the model there, and what we use is we use these state files, which Mark showed you a little bit earlier. Infrastructure management to us really is a data definition. And so we really just use state files to define the state your infrastructure is in, and if that state includes containers or microservices, that's how your infrastructure will be built. So this works very, very well with containers. We may be the biggest container orchestrator of Docker now, and we've worked, I think we were the first one to support Docker outside of their own native infrastructure.
Yeah, and just to kind of add to what Matt's saying, in my example, I spun up another VM. However, if NGINX was running on a container and something in that container broke, I could easily, instead of spinning up a VM, brought down a new container on the same host. We would treat that very similarly.
Yeah, effectively it's the same thing because it's a data structure, it's a defined data structure. You really can pick the tool which makes the most sense, and that's one of the things that's been sort of interesting to watch. I both have I'm sort of an older guy. I've been around this ride a couple of times, and it's been interesting to watch people really spin up about Docker and to get super excited about Docker, and there's a lot of froth. And if for anybody who's been around a couple of circuits on the track, it looks and feels very much like the virtualization wave that came. And in many ways, it's micro-virtualization, and it has lots and lots of advantages. But if you don't manage that coherently and pay attention to the downside, it can bite you pretty quick. You get a lot of duplicate services, you get a lot of unknown code, you have offline containers which aren't patched. And so using the part that makes the most sense for your particular use case, whether that's a big monolithic line of business app which crosses many servers and multiple databases and it's one big chunk of compiled blob code, or whether that's a bunch of microservices spread out over a hybrid infrastructure, SALT gives you the ability to pick the pieces that make the most sense to solve your need, and you don't get locked into one infrastructure or a really application technology stack. Another question we got, Mark, was asked, how do we display the active message bus? There's a couple ways to skin this cat. I thought I'd give you a crack at it. What's the best way? How do you like to see the message bus data?
So in my case, I use a, sorry about the echo. In my case, what I was using a command, and my slides just kind of went wacky on me, but I use a command, a runner. We have a state event runner that will actually output it to the terminal session that I'm in. So It's just salt run state.events, and then there's a switch called pretty equals true, which makes it consumable. There's other methodologies where you could actually have that event runner being returned into an external source. So, I've heard use cases of having it put into, kind of a web interface where it's streaming across there. Typically, you don't need to see that, but from a debug perspective, it's nice that we have runners that do that. You can also start the Salt Master in a mode that's a debug mode. That's really not good for production unless you have some serious problems, because you have to start and stop the master to do that. You also get extra information when you do that. But the event bus from itself, we have a runner called state.events that will stream that to the terminal, or you can use what we call returners to put that to a third-party, third-party utility or database or a web service or something.
I'm going to break my own rule here. I'm going to talk about a feature that's not quite released yet because I'm a product manager. This is actually one of the questions I get asked the most commonly is how do I view that event bus data? And traditionally in the command line, this is one of the things. The command line is really super cool and it's very, very powerful, but it has specific and very distinct limitations in certain areas. And viewing or reacting to the messaging bus is one of those. So one of the features of the enterprise product, which I talked about earlier, is the ability to view the message bus, so you can actually select a pre-created target group and click a view of that target group, which shows you the data coming across the message bus. We also have this really cool new feature coming called the e-filter. What the e-filter is the ability to filter for specific tags or events on that bus and filter those off to another data table. So for example, if you had, for example, you were looking for tags for failures or something like that, you would be able to filter those off, put those in a table, and report against those later. And then I also had one of our, and I love to see this, one of our top devs is also reminding me, and shout out to Mike Place. Nobody that's not Mike, email him, because if you even go talk to him for a second, like, it just slows us down a little bit. He also brought up the fact that Salt run state.event will show you the message bus. So thanks for the tip, Mike. I'd forgotten about that. But anyway, good question. Appreciate it. And it is one of the things we get most commonly is how do I see that data, and more importantly, how do I store it or then react to it later?
All right, thanks, Matt. I've got a couple questions also that came to me. One said, how do you add a newly added server into Nagios or MS operations? So essentially, similar to what I did with HAProxy, you would if the application was running on a node that had a minion on it, so like you had Nagios running on a Linux box, you could then do whatever you need to do to the application to configure it to show that so that it shows up in there. Same thing with Microsoft. We have minions that run on Windows. So typically, depending on the application, you may have to do different things. Typically, it's modifying ultimately that information is probably stored in a database or a configuration file, and you would just need to update that information there.
And was that the pillar data question?
No, it was. Matt asked me if that was a pillar data question, and it was just sent to me privately. The other question here is, how do you tell that the monitor minion to start watching over the new server? If I understand that question correctly, is how when the new node spins up, how do I tell it to now start monitoring that new node? If it's a third-party system, it would be similar to, you'd have to, however that application is configured, wherever that information ultimately is stored in that application, you would have to change that. Again, typically a configuration file or a database, and we have methodologies to update databases, or maybe an API call, similar to what I was doing with my Slack notifications. You may be able to configure that third-party system via API. If it's Salt, the beacon is stored in Pillar, and anytime NGINX is installed on a box, that minion gets that beacon information and automatically starts watching. That minion will automatically start watching the NGINX service in my example. So those are a couple of different ways that those things are done.
Okay, one of the other questions that we got asked, which I want to make sure everybody gets a chance to hear, is pillar data available in the orchestration state or event data from the triggering event only?
Yeah, yes, pillar data can absolutely be available in the orchestration state. The state file can be written to pull information from pillar. So if I understand that question correctly, and that could be either an orchestration file or a state file.
Perfect. And then one of the other questions, so a question just came in, it said, how would you build out a SaltStack infrastructure with HA and resilience in mind from the master's point of view? So how do you protect the master control layer?
There's several different ways you can do that. Matt mentioned that we work together at several companies, and one of those was specifically with HA in mind. And so we have Matt and I kind of have an interesting viewpoint of what true HA is, and what we have is the ability to do what we call a master-master configuration. So the minions are pointed to master A. If it loses communication with master A based on certain thresholds and timeouts, it'll start listening to communication from master B. It's kind of an HA light because in the product today we don't really have direct syncing of the information from master A to master B. The job caches aren't shared, so that's just not. I call it HA light. Matt's probably better to talk about some future roadmap stuff if we're planning that. That's kind of his purview, but we do have the ability to do a HA perspective so that master A goes down, master B can start issuing commands to those minions.
Yeah, good answer, Mark, and I will address this from a roadmap perspective. One of the ways that the SaltStack Enterprise product is being architected is that we have what is in effect the UI front end, which actually sits on top of or over separately from the masters, and that will include a shared file system. So from a roadmap perspective, we're actually moving more towards and I'm air quoting now, HA or highly available infrastructure. And to Mark's point, we have to be a little bit careful because HA has specific meanings, and we want to make sure that everybody's clear when we cross those boundaries from resiliency to disaster recovery to true multi-master HA. But that's definitely in the roadmap. It's something we're working on architecturally now, including some components such as the shared file system across all the masters, and the ability for multi-master control. In the first ship of the product in January or in early next year, you'll actually be able to control multiple masters, and you'll be able to have pre-saved target groups, which include minions across multiple masters. You won't have to go to each master to run the job. You'll run a job singularly, and it will just contact the correct masters, and the data and the state files are all shared across a distributed file system. So we're definitely moving that way. It's definitely something that's in our roadmap, and we're actively working towards the resiliency in the master level and making that easy for customers today. Good question. So that looks like all the questions for now. I guess if you'd like we got a couple minutes left. If you'd like to grab the QA form and ask any more questions, and if not, we really appreciate your time. And we're going to make this webcast available in a couple of days. And I'm going to turn the time back over to Rhett for some final housekeeping items and wrap it up. But we really appreciate your time and your interest in SaltStack today, and we're glad to spend time with you.
Yeah, thank you, Matt. Thank you, Mark, for this demo and the webinar and the information you provided. Yeah, just as a reminder, we did record it. We'll provide that recording to everybody who's registered for the webinar. If you want the slides in PDF, send me an email. You should have an email from me in your inbox right now. You can just reply to that, and I'll get those to you. And then shameless plug, as always, SaltConf 16 is coming up. If you like the content you heard here today, if you want to argue with Matt or Mark about any of the points they've made today in person, join us in Salt Lake City in April 2016. Go to saltconf.com for information. We've got an open call for speakers right now. We're looking for great talks. If you've got something, please submit a talk. It's the best way to get a free pass to SaltConf. And again, thanks to Matt and Mark. Thank you for joining, everybody. We will be in touch. Thank you. Bye.